Hello everybody and welcome to this workshop about advanced concepts in Compact and testing your smart contracts. We are going to see some of the concepts in Compact that are going to help you create more complex applications, and we are also going to see how to test your smart contracts once you wrote them and everything compiles. So we are going to go through different concepts in Compact that will help you achieve that goal. So here is what we're going to talk about today. So first we're going to have a quick intro about Compact. Then we're going to talk about structs in Compact and see how you can use them in your applications. We are also going to talk about modules, so how to create them, import them, export them, and also include some files in your applications. We are going to briefly talk about privacy in Compact and what you should be looking for when you write smart contracts to make sure that the data that you use in your smart contract is private. Then we are going to talk about the Typescript Target. So your contract is going to compile and the compiler is going to create some JavaScript files. We are also going to talk about set, map, and list and see how they can make your application more robust. And finally, we're going to talk about native tokens. So we are going to see how Compact helps you create native tokens, manage them, send them, receive them, and you're going to learn everything you need to know about native tokens if you want to implement them in your application. So let's get started. So here's a quick intro about Compact. This workshop is more of an advanced workshop about Compact, so you should already know some Compact before watching this workshop. But here's quickly what Compact is. So it's a smart contract language that's similar to TypeScript. So the syntax for the Compact language is close to TypeScript. That doesn't mean that this is TypeScript. It means that the syntax is similar, and you are going to see through this workshop that a lot of things that you can do in TypeScript are not possible in Compact, even if the syntax is the same. A Compact smart contract is compiled and then produces zero knowledge circuits, and those are the circuits that your application is going to interact with. It also produces a contract interface, so it's a JavaScript file that you are going to use in your application to interact with the contract. In general, the file that is output by the compiler is called index.cjs, and it's in the same folder with the Compact contract, and that's where you're going to find it. Recently, the Compact language has been taken by the Linux Foundation. It's being managed by the foundation, so it's an open source language, and you can learn all about it in our documentation. So let's talk about structs. Structs are a very important kind of data in Compact that you can use to manipulate data that the users are going to send to your contract. So what are structs? Structs are user-defined data with properties to store values of different types. So you're going to have different properties in a struct, and each property can have a different type, and in general all those properties are linked together by some logic. Structs are very similar to TypeScript objects, but they're also very different. If you know a language like Rust that also has structs, then they are very close to structs in Rust. But here we're going to keep comparing Compact to TypeScript, and the closest comparison that you can make with TypeScript is with objects. The main difference is that objects in TypeScript and JavaScript in general can have methods, so they can have functions that you can run from the object by calling the name of that function. And structs as just a collection of data, so there are no function. So here's how you declare a struct type in Compact. You use the struct keyword, and then you name the type of the struct. The convention is to use uppercase for the first character of the name. And then you open curly braces and you declare some properties and the type of these properties. So for example, for the first struct here, the thing struct, the first property is triple. It's called triple, so it's a vector, and the second property is called flag with the boolean, and the second struct is called number end. And the first property is called num. It's an inside integer of 32, and an item. And you can also have generic types in structs, just like you can in TypeScript. And then here the item is going to take whatever type that T represents. After you declare the type of a struct, then you can create a new struct, and that's how you do it in Compact. So you use the const keyword to create a new variable, you use the name of that struct, and if the struct has a generic type, you have to pass that generic type, and then you can just assign values to the different properties of the struct. In order to access the different properties of the struct, just like in TypeScript, you're going to use the dot notation. So you use the name of the struct that you declared, dot, and the name of the property that you want to access on the struct. So for example, for the num and struct, if you want to access the item property and the value in that property, you would call num and dot item. So once again, that's exactly the same thing like in JavaScript and in TypeScript. So there are a few structs that you are going to use a lot in your application. Those structs in general are imported from the standard library from Compact, and they are very useful structs that help you structure the data in your application. So for example, there is the maybe struct. So there is a kind of value in Compact that can be either none or some value. So there's no concept of undefined in Compact compared to TypeScript. So the maybe type is going to be very close to undefined. So if maybe is none, and then it means that there is no value, and otherwise if there's a value, the maybe is going to be some, and it's going to wrap that value. And the second struct is either. This one is very easy to understand. So either is a value with two branches, a left branch and a right branch, and you can put a value in either of the branch, but not the two at the same time. So a value of type either is either going to be on the left or on the right side, and then according to the position of the value, you can do something different in your application. And on the left and on the right side, as you can see from this example, you can have different type of value. So when you are going to receive a value of type either, you are going to be able to check if the value is on the left or on the right side, and then branch your application from there to decide what you want to do with that value according to the position of the value in the struct. And to finish, if you want to write any sort of application with tokens on Midnight, you are going to use the struct coin_info. That's going to represent the token, where you have different properties on that struct. So there is nonce that represent the token. The color of the token is the color of the token are some bytes that represent the token in the ledger. So each token is going to have a different color, and then the value is the amount of tokens that the coin_info holds. Now let's switch to modules. So it's possible in Compact, like in most modern languages, to split your code in different files, and then you can import and export the code to use it in other parts of your application. So the first thing that I would like to talk about is that include keyword. So in general, that's not really something that you're going to use a lot, but it's important to know about it. So include is going to be followed by the path to a file, and what it's going to do is just going to copy the content of that file directly in the file where you use the include keywords. So you don't really have a lot of control over that. It also creates some situations where there can be conflict between variable names. So if you use include, you may import namespace or a variable name that already exists in the file, and there's going to be a conflict with that, and you're going to get errors. So that's probably not something you want to do, but in some cases you want to include code like that, so that's when you're going to use it. Otherwise, you are going to use modules a lot. So modules are very practical for that. You can import some code, and then the compiler is going to complain if some variables already exist, some namespaces already exist, and things like that. So it's going to be better for to prevent some bugs in your application. So you use the module keyword, you name your module. Once again, the convention is to use the first character in uppercase for the name of the module. You open curly braces, and inside the module you can write code as if you were writing any other compact code in your main file. So for example, that's a module. As you can see, there are two circuits. So they are akin to functions in compact. Here we also export some things from the module, and the circuits are going to be available with the dot notation after the name of the module. The way to export a module is to give it the same name as the file where it's written. So you see here, for example, module is called m, and the file is m.compact. And then the compiler is going to look when you import m. The compiler is going to be looking for a file called m.compact and for the module m inside. So that's how you export the module. You don't need the export keyword. However, inside the module, you will need to export different types if you want to make them available outside of the module. Here is how you import the module. So for example, here there's a very simple module called runner with a circuit run. The first way of importing the module is just to call import runner, and now run is going to be in scope, so you can just call run directly, and it's going to use that circuit. Sometimes you don't want to do that. Sometimes you have multiple, or at least two circuits that have the same name. So there's going to be a conflict here, and the way to prevent that is to import the module and then use the prefix keyword and use a different prefix. And now if you want to call the run circuit, you will have to use that prefix followed by the name of the circuit. So for example, here import runner prefix some prefix. If you want to call run, you will have to call some prefix underscore run. That's how you prevent clashes between circuits that may have the same names. This is the fungible token contract that was written by OpenZeppelin. It's a very good example of how to declare a module, how to use it, and how to export different values from the module. So here you can see that from inside the module we import the standard library. We also import other modules inside that module, so it's very modular. It's also possible to export ledger values from the module. It's not possible to use a constructor inside the module, but you can declare ledger values inside the module and export them. So you see that's what here it's done by, for example, the map allowances or the total supply, and then you can export circuits from the module. So the inside the inside of the module works the same like a contract, except that you cannot use a constructor. And I would encourage you to check on GitHub. The OpenZeppelin contracts are open source, so you can check them. The code is very good, it's very clean, and it's a very good starting point for more complex applications on Midnight. So now let's talk a little bit about privacy in Compact. So the whole thing about Midnight is that the blockchain is private, and you can do a lot of private things in the blockchain. However, it's very easy to mess that privacy when you write your contract, and I'm going to tell you what you should be looking for when you write contracts to make sure that the data stay private. So the first thing to know is that all data is not private by default. It's not because you're writing a smart contract in Compact that everything that happens in the contract is private. Midnight has that mechanism where both public and private data are available on the blockchain. So they are public data, and you have to be mindful of the code you write to make sure that the data that you use is not made public if you want to keep it private. So you have to remember that all the data in the smart contract is not private by default. So for example, the arguments that you pass to a circuit are private. When your application calls a circuit, it's going to pass some arguments, and the arguments, when they reach the circuit, are private. So they're not visible, and they stay private until a certain point if you do certain actions. The data in the witness is private, so that's the whole point of the witness, to be able to pass private data from the user to the circuit. All that data is private, so arguments in circuits and the data returned by a witness is private. However, the data that's saved in the ledger is public. So all the data that's declared in Compact as ledger value is public, and it's visible on chain. So most of the cases where you're going to have a leak of privacy is when you are going to use private data and save them into the ledger where they're going to become public. That's why Compact introduces a few months ago explicit disclosure. So explicit disclosure is a way of the compiler to warn you that the data that was private is going to get public. So it's a function that you use to wrap data that is supposed to be private, but that's going to become public. So for example, here we have a witness get balance that's going to return some bytes. When you use it in your circuit, and if you don't use disclose here, the compiler is going to complain about it, because now you're saving the return value of get balance into balance, which is a ledger value. So that value coming from the witness is private, but as soon as you save it in the ledger, it's going to become public. And the compiler wants you to acknowledge that you know that, and that's why you have to wrap it into that disclose function and use explicit disclosure to understand that that value is becoming public. So now let's talk a little bit about the Typescript target. So after you write your smart contract, you're going to get some TypeScript code and some JavaScript code, and that's the one that you're going to use in your application to interact with your smart contract. After you compile the contract with the Compact compiler, you are going to get different sort of data, and among them you're going to get a contract interface that you are going to use to interact with the contract, and also some types that represent the types that are used in the contract. So here is the development process, the process that in general you go through in your application. In the first time, you are going to create a smart contract in Compact. You write all the code, you create that smart contract. After that, you compile it, so you pass it to the compiler, and the compiler is going to generate multiple items. So of course it's going to generate the circuits that you are then going to deploy on the blockchain. It's also going to create the contract interface. So the contract interface is a JavaScript file that you are going to use to interact with the contract, and you are also going to receive some types, so the types that are used in the contract and that are going to be available for you to interact with that contract. And then after you receive all those files, you are going to start writing your application in TypeScript, and you use the contract interface in the types in your application. So the contract interface is a file called index.cjs. In general, it's going to be in the folder where you have your contract. It's not mandatory. You can give it a different path when you compile the contract, but in general it's better to keep everything together. And the convention so far has been to generate all those files in the folder called managed. You can use another convention, but that's the one that you're going to find in our in our examples on GitHub. The compiler is also going to generate some types, so a file called index.d.cts, where you have a lot of different types. So type for the ledger, for the witness, for different values and data that you're going to use in your application. So here are some examples of the types and the things that you are going to get in the contract interface and in the type file. So for example, you get a type for the witnesses. So all the witnesses that you have in your application are going to be typed according to the value that they return. So that's what you get. You also get a type for the impure circuits. So Compact makes a difference between pure and impure circuits. Quickly, a circuit is pure if there are no side effects. So if you pass as argument the same values and you get the same value back, and there are no side effects, so no updating the ledger or that kind of thing. So that's a pure circuit. Impure, it means that there are some side effects. So for example, every time you update the ledger in your contract, that's a side effect, and that's an impure circuit. It also provides general circuits type for both impure and pure circuits. There is a contract class, so that's a very important one, and that's the one that you're going to use to interact with the contract. There's also a ledger type, so all the values that you use in your contract as ledger values are going to be typed, and you can import these types into your application to make sure that you pass the right value, and you get the right value when you check the state of the ledger. And there's also a constructor function for the ledger. Now let's have a quick look at sets, maps, and lists in Compact. So there are very interesting types that helps you do a lot of things in your contract and create more complex applications. So sets, maps, and lists are collections of data in Compact. So they help you group data together. They are going to group that data differently, and they have also different features that we are going to go through, so you can understand which one you need in your application, how to use them, and how to use them at the best of their capacity. So the first type of data that we're going to talk about are sets. So sets are a collection of values of the same type. So you can think about sets as a set in JavaScript. So you can put like different values inside the set, but they all have to be of the same type. So no access possible. It means that you cannot access the values in the set by index, for example. So that's why sets are very good if you don't need to retrieve elements from inside the set. So if you don't need to know the position of an element or something like that, it's very good, like just to group elements together and have a collection of those elements with no position if position is not important for your use case. There are a few methods that you can use directly on a value of type set. So I just listed a few examples, but there are other methods. For example, there is the insert method, where you can take an element of the value type of the set and insert it in the set. You can check if a set is empty. You can check if an element is a member of a set by calling the member method. For example, that function shows that set is very good for that. You just put data inside the set, and then you just want to check if that data exists or not. You don't want to retrieve that data. You can also remove a value from the set, and you can also check the size of the set. Now let's talk about maps. So maps are a collection of key and value pairs. So it means that you have a key that is going to be linked to a pair inside the map. So they're very good to access and retrieve values by their key. So as soon as you associate a key with a value, you can retrieve that value if you have the key. So one of the examples would be something like balances. So if you have the address of a user, you can link it to their balance. So the address is the key, the balance is the value, and every time you want to check the balance of a user, you just need their key and you can retrieve the balance of that user. So they are very good for large collections and quick retrieval of information. Because you have the key that is linked to that value, it's very easy and very quick to retrieve that value. And it's very good for large collections. So for example, a map of all the balances of all the users, that's something that you would use in a DeFi application, for example. There are different methods that are available on the value of type map. So for example, there is the insert method, where you just need the key and the value and it's going to insert it in the map. There is the lookup method, where if you have the key, you can get the value that's associated with that key. There is a remove method that helps you remove a value by its key, and you can also check the size of the map by calling the size method. To finish, let's have a look at lists. So lists are a collection of values of the same type. So in that sense, they are very similar to sets. The main difference with set is that in a list, only the head is directly accessible. The list works on the last in, first out principle. So you push values to a list, they come at the top of the list. And when you need to retrieve those values, you call the head and you get the head of the list. So there is no direct access by index, for example. And the value that's going to be directly accessible in a list is the value that's going to be at the head. So the last value that was pushed onto the list. Once again, there are different methods that are available on the list. So you can call the head method. That's going to get you the value that's at the head of the list. It returns, you can see we talked about the maybe struct. So here it returns a struct, the maybe struct, because if the list is empty, you're going to get none. And if there is a value at the head of the list, then you're going to get some, and some is going to wrap that value. You can check the length of a list, and if you use push front on the list, then you're going to add a new element at the head of the list. And to finish, let's talk about native tokens. They are very important in Midnight, and they work a little bit differently. So there are a few things that you need to know about. So the first thing to know is that so there is different types of tokens on Midnight. So there are shielded and unshielded tokens. So there are tokens that are private and tokens that are public. You have to be mindful of what kind of tokens you want to use in your application. The contracts themselves can mint tokens. So in general, for native tokens, you're going to write a smart contract and you're going to call some functions to mint tokens. And that's one of the main differences with, for example, the Ethereum world, where on Ethereum the tokens are bound to a contract. On Midnight, because of the UTXO system, the contract can mint tokens, and they're going to take ownership of these tokens, but then they can send the tokens to an address and release ownership of these tokens. So native tokens actually leave the contract and they go to a wallet, and then from your wallet, when you send tokens, they actually leave your wallet. So they are not bound to a contract. So that's what I was explaining, that the contracts can take ownership of tokens, not only when you mint tokens, but also when you send tokens to a contract. The contract is going to take ownership of these tokens. So how do you create and manage tokens in Compact? So there are different things that we are going to go through here to understand token management in Compact and on Midnight in general. The first step is going to be minting tokens. So there is here a function. That function is available in the kernel of the contract. So you would call kernel.mint, and it's going to mint some tokens with a specific domain separator. and the amount. So here you mint tokens and the contract takes ownership of them. Otherwise, in the standard library, there is a circuit called mint token that's going to allow you to mint a new token and also assign already an address to it for a recipient. So if you want to mint tokens and send them directly to a user, that's the circuit you are going to use. If you just want to mint tokens and have the contract take ownership of these tokens, you're going to call that mint function. The second steps will be to send tokens. Once again, in the standard library, there is a circuit called send, where you can see it takes different kind of arguments, and then it creates a result that you can inspect, and it's going to send tokens. So it's going to release ownership of the tokens from the contract and give ownership of these tokens to another address. There's also a send immediate circuit. The difference is that send immediate is going to use some tokens that are already part of the transaction, and is going to send them to a recipient. And after you send tokens, you can also receive tokens. Once again, in the standard library, there is a receive method that you can use to receive tokens. So it's a very important part of Compact, is that when the circuit of a smart contract is expecting tokens, you have to explicitly receive them by calling that receive circuit. There are also different things that you can do with tokens. So you can manage tokens. So for example, there is a circuit called merge coin that takes two different UTXOs of tokens and is going to merge them together. There's also a burn address. So here you can get a burn address where you can send the tokens and burn them. You can also store tokens in the contract. So for example, in the map, as we saw a little bit earlier, there is a special method called insert coin, and that's different from just insert, because you can use it to insert coin into the map. So it's very specific to token management. There is the same method in list that's called push from coin, where you can push some coin info to a list, and there's also the same method on a set, where you can insert coin info into a set. And to finish, there are some token types that help you manage tokens on Midnight. There is, for example, the struct coin info that we talked about a little bit earlier, and there's also a qualify coin info. So this one's for a token that already exists, and there's already a balance. So there are those two token types that you can manipulate in your smart contract. Either you create new tokens or you manipulate and manage tokens that already exist. So, and that's it for this presentation. Thank you very much for watching. I hope you learn more advanced concept of Compact. If you want to know more, you can check our documentation. It's online, it's available. There are a lot of details, and it will help you create better applications and more complex applications. Thank you very much.